For most populations, food is actually the major exposure route, for multiple reasons. It's because some of it gets into our food when it's grown, whether it's getting into, for example, cattle and other animals, or whether it's getting into plants. It's getting into our food from the plastics, where a single dose, unless it's pretty high, is not going to do much, but repeated chronic exposure can have major effects.
So what are scientists doing to understand or even mitigate the risks PFAS pose to human health? To answer this question, we interviewed scientists from different fields, ranging from developmental biology to environmental engineering, in order to gain a complete perspective of current PFAS research. In their research, scientists are examining the biological mechanisms behind the health effects associated with PFAS. The goal of these studies is to see how different types and concentrations of PFAS can impact personal health. To do this, they often use animal models like fish and mice and will carefully expose them to a certain level of PFAS. We spoke with Dr. Alicia Timme-Laragy, a developmental toxicologist and professor of environmental health sciences at UMASS Amherst. She is currently using zebrafish to understand how PFAS can harm embryo development at the cellular level.
So in a fish embryo, if your pancreas is not, properly formed, or if there's a delay in how it is maturing, then that can affect how the embryo is utilizing its nutrients. And kind of what we see is that, at least with some of the PFAS we've looked at, those nutrient usage wheels they're kind of spinning in the mud, and they're not really going anywhere, which means that they're, the limited nutrients that are put into the yolk sac that is supposed to sustain these fish until they start feeding independently gets used up faster than it normally should, which creates a big survival stress. So by looking at, how the pancreas is forming in the fish, it has strong translatability for how the pancreas would be forming in a human. So when we see things like issues with insulin secretion or insulin misfolding or exocrine pancreatic insufficiency, hyperinsulinemia, all of these can, not only impair the growth of that embryo, but it's not that far of a leap to say this could also happen in a human.